How far did you, by the way, get on
On the test?
Mm-hmm.
Pretty far. I think I got most of the problems done.
Yeah, I looked at it, worked a few problems.
Yeah.
Just no motivation.
Yeah, I don't...
Oh, did you see that one YouTube video?
Yeah.
On Ruth's page?
Yeah. Yeah. I didn't know he was a Beaver fan.
Me either.
Yeah.
Me
You just
either.
don't know sometimes.
I know. He went to the concert too.
Yeah, I think he actually got a picture with him too.
Oh my. Well, I mean, makes him happy.
Yeah. Whatever makes him happy.
Well, what do you call? How long did it take you to finish? Are we going to work on this really?
I don't know, but I mean, we can get to it. I spent about an hour something on it, hour and a half.
Mm-hmm.
I don't know.
And did you finish?
Yeah, for the most part. I think I had one thing that we could go over, but not really.
Did you use that node current analysis method on
Yeah.
problem 5?
Exactly. I think we should go over that node analysis problem a little later. I actually had one more thing I wanted to show you. Have you ever been to quicklinks.com?
No.
Oh, really? You've never seen Bad Luck Brian?
Yeah, I've seen like a couple of his.
Oh, okay. Let me show you some. They're hilarious. Here's a really good one.
Takes Benadryl from allergies, dies from allergic reaction. That's so horrible.
They're pretty bad.
Should we? I really need help on this nodal analysis.
Really?
Mm-hmm. I mean, because, like, weird. The problem is asking which one's easier, nodal or mesh, and, like, how do you pick which one is easier? Like, is it this way?
We could probably just go over that later. I should think we should go over problem 3.
Yeah. And then we can come back to nodal?
Hey, did I get
Yeah.
a problem? Are you guys in E215?
Yeah.
Problem 3?
Yeah.
I've been like working like 2 hours on that problem. I haven't gotten much at all. Do you mind if I get some help?
No, not a
Yeah,
problem.
let me see.
Awesome. I could really use it. I gotta get going and I really don't get this problem, so.
What do you
Super
know?
helpful.
Do you guys mind if I join?
Yeah.
I have some doubts too, and
No, just
Yeah.
let me see.
Easier to get.
Yeah,
No, it's
but-
not a problem.
Perfect. So I pretty much got the first part of adding up the 10,000, the 3,000, and the two 10,000s to get
Okay.
24,000.
Awesome.
And I know we're supposed to use Ohm's Law to look it up in the textbook, but I don't really know what you're supposed to do with Ohm's Law.
You're just supposed to rearrange it because you're looking for current. So you have V equals I times R, right?
Yep, so I got it.
Okay. And then you just rearrange it where you're solving for I, which is current. So I equals V divided by R.
Okay. But we don't have V.
Yeah, it's actually it's given.
yeah,
Yes.
you substituted.
Oh, 24.
Yeah, Ruth has the right idea.
Okay.
So it's just 24 divided by 24,000, and that's going to give you 0.001.
Yeah.
Is that how you guys got it?
Mm-hmm.
Okay, yep, that makes sense.
Cool.
Yeah,
And then for the last part, we're just finding the voltage drop.
that's
Okay.
where I got stuck. I didn't know which two resistors we had to add.
Oh, it's just the first two, the 1,000 and the 3,000 ohm resistors.
Oh, I thought we
How'd you know that the first two?
Because it was right after. It was placed right in the middle, so it was just meaning the first two. Yeah.
Or did you think that it was across the two, the 3,000?
Yeah, I thought that too. That's why I kind of got 13,000 ohms here.
It's just the voltage, just the drop. You're just considering the voltage drop across the two resistors.
Oh yeah, actually
So-
yeah. Yeah, I mean that makes sense.
Alright, cool.
And then you'd get like 4,000 ohms, and then
Yeah.
substitute the I from.
Yeah, the 0.001 that we found.
Uh,
And then that should give you 4 volts. And then I think just the last part is subtracting the 4 from the 24.
why would we do that?
Because we want the voltage after the voltage drop. So the voltage drop is 4
Oh,
volts.
it's only part of it.
Yeah.
Got it.
Does that make sense?
So that means 20?
Yep. Exactly.
And then you see when the current is coming like this, it goes from minus to plus, but when it comes to it goes from plus to minus.
Uh-huh.
So the polarity is reversed.
Yeah.
So, and then you'd have to subtract.
Okay.
You guys got it?
Good trick. Yeah, I think that's perfect. I actually have a question about number 6 too, so maybe we can do that one. Don't worry if you have another one you just want to use
No,
that.
6 sounds good. Is everyone good with 6?
Mm-hmm.
Cool.